All right, we have a little bit of a different type of system now. We have been solving systems different ways. We've been setting up systems, and back at 11.1 we solved systems by graphing. We're going to do the same thing, except this time instead of solving a linear system, we're going to solve a linear system of inequalities, meaning we got these greater than or less than. So they want us to solve this system. There's two equations in there, but they're both inequalities this time. So the equation for this boundary line here is just x plus 3y equals 3. I don't know why I put the 3 there. Let's write that again. X plus 3y equals 3. So we can get our x and y intercepts of this real quick. If I cover that up, I get my y-intercept of y equals 1. I get my x-intercept. If I cover this guy up right here, my x-intercept is 3. And my inequality symbol is up, right? It's greater than. So let's see, we use the inequality of greater than. It does, so we're going to use the dashed line because there's no equal. And we're going to shade, since it's greater than, we're going to shade above. So let's go ahead and do this. All right, let's graph it. The y-intercept is 1. I so wish they hadn't gone by 2's, but it's about there. The x-intercept's 4, which is about there. If I go like this, right, and I'm going to shade up, I'm going to shade really light up like this. Oh, there we go. Alright. Now let's look at this guy right here. I should have a pencil on me. I've been using pen for some reason, although it's erasable. Alright. So the boundary line for this guy is negative x plus y equals 6. Right? So the x-intercept, if I cover my y, is negative 6. The y-intercept, if I cover my x, is just 6. The inequality, so we're going to use a solid line, right? Solid. Let's go ahead and graph it. We've got 6 here for the x-intercept. Oh no, x-intercept's negative 6. Negative 6 over here. Y-intercept is 6 right here. And then we're going to use a solid line to go through that, right? And we can see that it says less than, right? So we're going to end up taking that and shading it down. Now, out here we got shaded, but over here we have 2 shaded areas. You can kind of see where there's 2 shaded areas, right? So let's go ahead and look it on the other side. All right. I'm going to graph this again. Let's get that negative 6 and 6. And then shade this way. Alright. I'm going to get that 1/2, and I believe it was 4, like this. And shade it this way. And then we got that region where everything was shaded more than once right in here, right? This is the dark double shaded region. Above. Or below. That one was below. Alright. So, identify the solution. They're represented by the overlapping, right? Where everything was shaded. Check your answers. So, that means anything that's, so let's check 0, 0. 0, 0 should make one of them true because it's in this shaded region, but not that one. If I plug in 0, 0 here, I get 0 is greater than 3. That's not true. If I plug in 0, 0, I get 0 is less than or equal to 6. That's true. Overlapping in the shaded regions? No, because it's only in one of the shaded regions here. Let's test 2, 3. Let's look where it should be. 2, 3 should be in both, right? 2, 3 should be in there. It's in the shaded region. So if I plug in 2 and 3, I get 11 is greater than 3. That's true. 2 and 3, I get 1 is less than or equal to 6. Also true. And I'm just plugging in those into the equations. That's yes. It makes both equations true. If I plug in negative 8, 2, well, you know what? I'm just going to use the graph for this one. Negative 8, 2. Negative 8, 2 is right there. That's no for both. So no. Negative 4, 6. Negative 4, 6. That would be yes for this one because it's above that line, and no for this one because it's not below that line. So it's not a solution. Why is 0, 0 a good point to check? All right. 0, 0, makes both variables cancel out. That's very easy to check. It's very easy to plug that in. That's actually your first 2 pages. So there's not too many pages. We're going to pause this and talk to you soon.